Hi class, today we are going over lesson 1.9, how to understand scientific notation. So let's start off with the definition here. What is scientific notation? So scientific notation is a way we can rewrite our number we are working with as a number times a multiple of 10. So we do this to make our numbers look more clean. Now, clean is obviously a subjective word right there, but what I really mean is that it looks like a neater number and it is easier to work with. So our first factor, if we want to look over here, the first factor is always a number that is greater than or equal to 1, and it's going to have to be less than 10. The reason is the number after our digit right here is going to have to be a single digit. So like 10 takes up 2 digits, so that one wouldn't work. So the first digit is going to be a number 1 through 9. The second, what we're multiplying by, is going to be a power of 10. So it could be 10 to the first, 10 to the second, 10 to the third, but it'll be a certain power of 10 depending on how many digits we have to move. So the way we're going to do this is we are going to place our decimal place after our first non-zero digit. So for example, if we're looking at the number like 92,960,000, then we're going to put our decimal after our first non-zero digit, which would be after the 9, because it's the first non-zero digit. And then you're going to count the number of places you have to move to that decimal place. So we have to move 1, 2, 3, 4, 5, 6, 7. So we could rewrite this as 9.296 times 10 to the amount of decimal places we moved, which was here, it was 7. And that's exactly what they got down here. So again, this is very similar to what we did in class yesterday, where we were learning the different expanded forms using powers of 10 to estimate our quantities. Now we are specifically doing it with a scientific notation. Alrighty, so for our key concept today, scientific notation is a way to write very large numbers or very small numbers. Scientists use scientific notation as a more efficient and convenient way of writing such numbers. A number in scientific notation is the product of two factors. The first factor must be greater than or equal to 1 and less than 10. The second factor is always a power of 10. All right, so let's get going on an example here. So the sun is 1.5 times 10 to the 8th kilometers from Earth, and we want to write this in expanded form. All right, so we have 1.5 times 10 to the 8th. So obviously when it says 10 to the 8th here, that means we are multiplying by 10 8 times. So what I need to do here is I need to move my decimal place 1, 2, 3, 4, 5, 6, 7, 8 spots. My new decimal place is going to be right here. And now I just have to go back and fill in all of these spaces with zeros. Like so. So that means when we say that the sun is 1.5 times 10 to the 8th kilometers from Earth, what we are actually saying is this is 150 million kilometers from Earth in expanded notation. However, we can write it using scientific notation as 1.5 times 10 to the 8th in order to save ourselves some room and some work. Okay, let's go on to another example here. So our second example, we want to write the number 0. A lot of zeros and then 587 in scientific notation. Okay, so obviously we need to find our decimal place. It is the first, the decimal place after the first non-zero digit. If we're looking over here, all of these zeros we could skip past, keep skipping. Then we reach our first number here, which is 5, which means our decimal place needs to go to the right of 5. So in this problem, we are going to have 5.87. Now, we have to find out how many factors of 10 we are going to need to multiply it by. So what we need to do is we're going to count how far we need to move this decimal. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 spots. So 16 spots here. Which means I can rewrite this as 5.87 times 10 to the 16th. Now think about it though. If I did 5.87 times 10 to the 16th, this number would get larger here, right? But we don't want it to get larger. We want it to get smaller. So this should be a 10 to the negative 16 power there. So if we want to rewrite that big long decimal there in scientific notation, we can rewrite it as 5.87 times 10 to the negative 16th. All right, let's go to another example here, our last one for the day. We want to express 80,000 in scientific notation. So again, we want to find our first non-zero digit here, and that would be 8. So I need to place my decimal to the right of 8. So here we know we're going to be doing 8 times something. Now we just need to see how far we're going to move our decimal. So we're moving it 1, 2, 3, 4 spots. So I could rewrite this as 8 times 10 to the power of 4. Now let's think, should it be a positive 4 or a negative 4? Well, that 8 is going to need to get larger, right? Not smaller, so it should indeed be a positive 4 because our decimal is going to be moving to the right. Alrighty, guys, so for your conclusion, make sure you're writing 2 complete sentences here. Today we talked about expressing numbers in more simple forms using scientific notation. Alrighty, everybody, I'll see you in class tomorrow. Have a great rest of your day. Peace out, everybody.